Welcome, Calculus BC. This is lesson 8.5, interval of convergence. Let's go. So a few more things about power series. Sometimes we want to figure out the radius of convergence and the interval of convergence. And this is going to be important in problems like this one right here. See how we usually had asked when does it converge, or does it converge or diverge? But I got this x in here now. So basically we're trying to figure out which values of x will this converge at and which will it diverge. So that's the whole point of this lesson. Now, we want to find the radiance of convergence. So we want to figure out how far out from it's the distance to the center C to how far away from C that x can go. So if you got your C's in the center, and you got your x, like how far out x to negative x can it go and still converge? So which values does it work for? Or like what is this length, this radius? And if you're thinking like circle, it's like if this was the center, the radius of the circle is 1. It can go both directions, but the radius is still 1. Now, the interval of convergence is actually just telling me what's the range of those x values. So, the range of the x values in here would be from -1 to 1. So that's kind of what we're doing. We're going to an example like this and looking at that x value and figuring out, well, how far away can that x be from the center, and what are the values? All right. And one thing, when we check the interval, you also need to check if the endpoints converge. So we're doing all this through the ratio test. We learned that last section. Remember, it converges if it's less than 1. It's inconclusive if it equals 1. That means we have to use a different test with the ratio test. And if it's bigger than 1, it diverges. So let's use this one. Ratio test. I'm going to set it up. So I set it up as the limit as n goes to infinity of the absolute value of 2 to the n plus 1 times x to the n plus 1 over n plus 1 times the reciprocal of this thing, n over 2 to the n, x to the n. All right. So, and again, to converge, this has to be less than 1. So let's put that in there. Now I'm going to do canceling. So 2 to the n cancels with that, just left with 1, 2, because there's an extra here. Most of the x's cancel out, but the top has an extra x, so I'm going to put it there. And the n plus 1, we can't cancel that. That kills kittens. So I'm left with 2x to the n over n plus 1. Now, and that's going to be less than 1. Now, one thing here. I know I have n's and x's, and that gets weird. But we're gonna simplify this limit thing. Get rid of it first. So treat x like it's like a number right now. It doesn't matter. We're plugging in for the n's right here. And we have n to the 1 degree over n to the 1 degree. And if you remember with L'Hopital's rule and how this works, all we're looking at is the highest degree term, so I'm ignoring this one. And since they're the same degree, the limit is just the coefficients of those two. So I can write this as the absolute value of 2x over 1 is less than 1. Okay. Now, the goal is to solve for x when we're doing this. So what I'm going to do, I went down too far. I'm going to write this again as 2x is less than 1. I'm going to divide by 2 on both sides. And these cancel out, so the absolute value of x is less than 1/2. To rewrite that as an interval, I can rewrite that as it goes from -1/2 is less than x, which is less than +1/2. So here's the start of my interval of convergence. Now, one thing I can say is right now, my radius convergence, so I'm going to say my radius is going to equal 2, or equal 1/2. So the radius of convergence is 1/2 because it's going out to the right 1/2 and to the negative 1/2. Now I need to check the endpoint. So I need to check two values. I need to check when x equals -1/2. I'm going to plug in -1/2 for x. I'm going to drag this down so I can see it. And I'm going to see what happens there, and I'm going to have to use a different test. I cannot use the ratio test. So here's what it looks like. It's going to be the sum of 2 to the n times -1/2 to the n over n. So when I have 2 to the n and -1/2 to the n, that's actually going to be equivalent to the sum of -1, like 2 times -1/2, -1 to the n over n. And this is an alternating series, and this is actually going to converge by the alternating series test. So I'm good. Now, let's check when x equals positive 1/2. So very similar. It's going to be 2 to the n times 1/2 to the n over n. And that's going to simplify to the sum of just 1 to the n over n, which is just the sum of 1 over n. And we know this one diverges by p series. So when I'm going to say my interval of convergence, I'm going to go back to this answer. It's going to include negative 1/2, so I'm going to put an or equals to there, but it will not include positive 1/2, so my interval of convergence is this thing. A lot of work, I know. Sorry. All right. Hands dying a little bit. Haven't done this in a while. Geez. Let's try skipping these for a little bit. I'm going to try this one. So this is going to be interesting. Same thing. We're just going to try the test. So ratio test sets up the limit as n goes to infinity of, it's going to be n plus 1 factorial times x to the n plus 1 all over, or times n to the factorial x to the n. You have to play the cancel game. Most of the x's cancel out. Factorials, what happens when you expand this is you're actually going to have everything except this top will have an extra n plus 1. So this rewrites into the limit as n goes to infinity of n plus 1 times x. Okay, and again, that has to be less than 1 and less than 1. Well, if you plug in infinity, this is not dividing by anything. You're just going to get infinity less than 1, because it's going to be infinity. Like, when is this actually going to work? So this is just infinity. But this is the only time that this is actually going to work is when x equals 0. So when the 0 is in here, this will actually be less than 1. So we can say my radius is going to be 0. And your interval of convergence is just x equals 0. So this only works when x equals 0, which kind of makes sense because that means this whole thing is 0. And otherwise, n factorial is not something that converges, that diverges. So there's your answer. So yeah, sometimes the radius can be 0. I'm going to skip extra problems, and we'll do more in class. Bye.